right, welcome everybody.
Hey guys.
And thanks for joining us for our February live stream. We're going to be letting everybody get a chance to join, and then we'll start taking your questions. But in the meantime, Darren, I have a pre-queued question.
Oh, okay.
So, pretty simple.
Okay.
Sean asks, this is from our How to Prove a Bad Furnace Motor video. What gauge Wago connectors do you use for the furnace wires? And also, if they're in our Amazon store, you can let people know, and we'll.
Wago. You say Wago, I say Wago. The Wago connectors have two types. One is rated for 20 amps. One is rated for 30 amps. Okay. I think 422 dash. Don't make me a liar. Anyway, so there's the big ones and the small ones. One's rated for 30. The smaller ones are rated for 20. And then they come with 2 cages, 3 cages, or 5 cages. Spring clamps. So for a furnace, it's never ever going to see more than 10 amps, maybe 11. So you can safely go with the smaller of the two, okay, the smaller spring clamp type connections. We do have those, I believe, on our Amazon affiliate store. I guess the easiest way to get to our store for Amazon things, if you want to show us some love, buy it anyway. But I mean, if you wanted to go through us, we get a little kickback. It's like 2 to 3%, depending on the category. But you go to our website, myrvworks.com, you click on the little orange box that says something around tools or something, and then it's our store. So you click that, and it'll bring you right into the Amazon store. We could probably do a little bit better to create the little thumbnails a little bit more, make sense, but at least if you ignore the thumbnails of the categories and you look at what the headings are called, it turns out that every time we add something to that store, to that category, that last thing we added, if I added 10 things, the last thing I added becomes the thumbnail. So it's like, now I gotta go fix all the thumbnails again. Anyway, that to me would be something under shop supplies, was probably where those connectors are. Love them. On the Wago connectors, these are the spring clamp. I have tried several different brands, and there's some that are orange also, but you can't find the manufacturer's name on them. Stay away from those. They are absolutely terrible. They won't hold the wire inside. I've seen them fail. You've got some that are red, a little bit better, but even still I've seen those fail. So the ones that are the Wago branded ones that come from Wago, the good German company, have had no problems with those at all. They really hold up well. And so I think that all the negative press that these spring clamp connectors are getting are because people aren't using the better quality ones. They're getting the copycat ones. So anyway, there's my answer on the connectors. But yeah, that's pretty much what I'm going to use when I'm going to connect just about anything in an RV. They're vibration proof, they hold really well, and it makes it really super easy to service the product later. You can just flip the little gate open, pull the wire out, pull the furnace, water heater, whatever. So there's that answer.
All right. So thanks for joining us, and we are going to get started with your questions in just a minute. Feel free to go ahead and post those. So just a reminder, we are here monthly, the first Friday of every month at 4:30 p.m. Pacific time, and we take your questions live, your RV troubleshooting questions, and try to give you some answers. And so if you have an RV related question, you can go ahead and post that in the chat. And just a couple tips, let us know the manufacturer and the model number of the system you're referring to. So if it's a slide, let us know, is it a Lippert, is it a Accu slide, you know, what's the model and manufacturer number of the specific system, not your RV. We don't care what year it is.
That
so
doesn't
much.
help, yeah.
And whether it's a Winnebago or, you know, Airstream,
it's
or
not
whatever.
that we don't care, it just that doesn't help us figure out the appliance.
And also, you are limited to a certain number of characters in that chat. So if you need to use up a couple of chats to explain your question, feel free to do that. We'll go ahead and figure it out and piece it together. And then just before you post, just give it a quick look over. It's really hard to read autocorrect. Sometimes that makes it very confusing. And hang in here for your questions. So we will let you know when we are done taking questions. Yeah, hang in there, because if we are asking your question and maybe we need a little more detail, if you're still here, then you can have a chance to respond and maybe get a better answer to your question. So go ahead and put those questions in. I'm going to ask you one more pre-queued
Okay.
questions, and then we'll see if we have some in the live. So this is from our Should You Protect RV LP lines in the winter. So Sue asks, what temperature level should you start thinking about covering the propane tank? We're stationary full-timers and have an 80-gallon horizontal tank. No one else in our park has theirs covered. We live in Idaho. The weather has been pretty mild this month. Thanks for sharing. That was about a month ago.
Okay. Propane. Propane follows the gas law. The gas law is an evil law. I don't like the gas law. So basically the gas law says that the colder it gets, the less vaporization you have. So the colder your cylinder gets, or the colder your ASME tank gets, the less vaporization you're going to get out of that tank. And you then will have issues running your furnace or running your gas appliances. So how cold? Well, minus 44 is a temperature that LP will stop vaporizing. So that is to say, if this was a cup of propane and it's a liquid, and so now we're out ice fishing, out there, and so it's below minus 44, so it's minus 45, minus 46, minus 50. Well, I've got liquid propane right here in my cup. It's sweet tea, okay? But as soon as we go into the tent from our ice fishing and it goes above minus 44, so now we've got the heat going in our tent. There's our fishing hole, and now we've got it in there a nice toasty 30 degrees or something. Anything over minus 44 degrees, my little 1 cup of liquid propane will vaporize 270 times as a vapor. So in order for, so we say that the boiling point or the vaporization point of propane is above minus 44. The analogy there would be if we were in our kitchen, we're going to boil some water, and I had a cup of water. Well, the water is a liquid, and when I get to 212 degrees, the liquid water becomes a vapor. So in water, it's 212, LP minus 44. So propane is going to vaporize at minus 44, water is going to vaporize at 212. So the tanks, the closer they get to minus 44, the less they're going to want to vaporize. So I have seen tanks work just fine down to 0, down to minus 20. They work just fine. But when you start getting lower than that, they don't have enough heat in the atmosphere, and they're getting too close, and you're not going to have that vaporization. Now we purchase and we store propane as a liquid under pressure, but we don't use propane as a liquid in our RVs. We use propane in our RVs as a vapor. And so all your propane lines throughout your RV are running propane as a vapor, and it's about 6 ounces of PSI. So 6 PSI, very, very small, very, very small pressure amount in there. We don't talk about that pressure as PSI. We talk about it at inches of water column. So I could talk about speed as either miles per hour or kilometers per hour or something like that. So we're still going the same exact distance, the same exact speed, but we use different scales, okay? Canada uses kilometers. Down here in the States, we use miles per hour. So in gas vacuums and things like that, we don't really use 6 ounces of PSI. We would say inches of water column. So it's just another scale that we use. So at what temperature should you keep your tanks warm? The colder it gets, the more I would look at heating my tank. Now, you said you had an 80-pound cylinder. That's a good size cylinder. For those of you who have the barbecue size cylinders, little 20-pounders, 30-pounders, 40-pounders, once that cylinder gets below half full, okay, or half empty, depending on if you're an optimist or a pessimist, it's not going to vaporize as much. So what that means is you might pick up your cylinder and nothing else is coming out of it. No more vapor is coming out of your little cylinder. Let's just go with a 20-pound cylinder. On that note, a 20-pound cylinder, if you're running your furnace constantly, a 20-pound cylinder, the little barbecue size ones will last you about three days, ballpark. That's just how long you have your furnace on, but just expect 3 days of use out of it if you're really running your furnace a lot. But you might pick up that furnace, that cylinder, and you can hear you still have some liquid in that cylinder. You can still hear, like, wait, there's still some in there. But you can't get to it because it's not going to vaporize. It's too cold to vaporize. So it's possible you're floating around there with some, a little bit of liquid propane in your cylinder, but you just can't, it won't vaporize. It's too cold. So what we recommend on that situation is to keep your tanks full, okay? So that is to say, if it's really cold and you have a cylinder that is half full, half empty, treat that as an empty cylinder, is what I'm saying. Especially if you have the smaller 20-pound cylinders, 30-pound cylinders. So when they get down to half, go get it filled again, and then that'll keep you going. So that they do have blankets. There's companies out there that sell professional, companies that sell the really legit cylinder blankets that you put them on there. It's like a giant heating blanket on there. Anyway, the colder your cylinders are going to get, the less vaporization the tank's going to generate, and you will have propane issues throughout your RV.
All right, and JJ says, hi, I
JJ.
see he watches our channel, thank you.
Hey, thanks, JJ.
I want to know, with old control boards, what do you do? Put them in the garbage, recycling? How do you get rid of those?
Like a DSI board for a furnace, water heater,
would assume,
refrigerator?
yeah.
Yeah, I throw it away. I've got a few that I've kept for my show and tell that I do plan on doing things with. But yeah, basically I'm just gonna, maybe there's a proper way to get rid of that, but yeah, I'm just gonna throw it in the trash. Sorry, I don't know if that's the right environmental answer, but that's what I'm gonna do to it, is just chuck it.
Okay, and now we have a question from Emily, who I think must have seen a couple of our videos and heard your comment on a hot water heater.
Oh,
She
it's not a
says,
hot
"I
water
have a
heater."
hot
Oh,
water
no, okay.
heater.
That's
Okay.
if it's a hot water heater, that doesn't make sense to me because the water's, it's actually a cold water heater.
Yeah, I'm sure.
Yeah, it's a cold water heater. If the water's already hot, you're not heating it. So anyway.
Okay, so I think, let me know if this is an Atwood. She says GC6AA-10E.
I believe those are going to be
Domestic?
Atwood.
I
Yeah,
think
because
so.
I think Suburbans start with an S.
Okay,
Yeah.
so she says, my tank blew up when it froze.
Sorry.
I either need to track down a tank or replace the whole unit. Do you have a video where you put in a 10-gallon replacement unit, or can you make one? They make direct replacements of another brand, but I would like to see a video on it being upgraded.
Sure. Okay. Yeah, we do. We've got one. It's on our water heater playlist. It was the one where it was snowing. Well, it wasn't snowing when we did the job, but there was snow on the ground. Now, you have a couple options on that, but if you have an Atwood, you're not going to find an Atwood tank because they got bought out, so now it's a Dometic tank. But the Atwoods, I might have these exactly backwards, but like one manufacturer, their tanks are, the hole you make in the side of your RV is a square, and the other one's more of a rectangle. And so they're, unless you want to do some body work, they're not really interchangeable, okay? Easily. We've done that, but we've had to cut into the RV to make it fit, and then you just kind of put over the other side. But so anyway, if it's an Atwood water heater, or a hot water heater, I think it's a hot water tank in a water heater, maybe. I don't know, but we can get into the syntax of what they're called later. But so you can replace just the tank itself, just the tank, and what that means, they're not that expensive that way. You're just buying just the raw tank, and then you take your stuff out, and then you take all the parts off of your bad water heater, and you move them over to your good water heater. Don't recommend that. That is a major pain because they have these rings that are put over the exhaust port, and good luck trying to find. I had a tool that fit over that. I don't remember what it is. Shoot. I don't remember what tool I was using, but yeah, that's really hard to do. I mean, the biggest challenge to doing it that way is like when you make a tricycle or a playground, they have those little one-way little washers that you tap onto this piece of steel and it keeps the wheel on. I don't know what they're called, but it's like a keeper ring. You're fighting those things, but these things are really good size, about the size of a soda can, that you have to get off of the old tank and then figure out how to put it back on the new tank. It is not fun. And so for that reason right there, I usually don't do that. I recommend people just buy the new tank. And that means you're going to have duplicate a DSI board, you're going to have duplicate this, duplicate that, blah, blah, blah. So if you have an Atwood, you could easily do a web search and put in your part number, and then it'll, what's the replacement for this, and it's going to give you a Dometic part number. When you put your Dometic tank in, your plumbing fittings are going to change a little bit, and we go into that in that video where there's snow on the ground. The output where the water goes in and the water goes out on that water heater on the Atwoods, they're like 3 o'clock and 9 o'clock. On the Dometic, they're at 12 o'clock and 6 o'clock. So you have to make sure that your plumbing lines, you need to take into consideration elbows and turns to change that. Sometimes you don't have a lot of room with the plumbing lines and you got to make a fancy loop to get it to double back on itself. But the other thing is on the Atwood, I might have this exactly backwards, but on the Atwoods, the threads are male, and on the Dometic, they're female, or vice versa. So you have to change some of the plumbings that way. The other thing, if you're going to go from the Atwood tank to a Dometic tank, the gas line comes in at a different angle. So be careful when you're bending that copper tube, because it comes in at a different angle, more of a dog leg into the thing. So just go in with eyes wide open. You shouldn't have a problem, but know that you're going to need some plumbing fittings on the back. You got to change the gender of your pipe fittings, and your gas line's going to change. But it will fit in the same size hole. And the Dometic water heater is, I think, physically smaller in the hole, but they do have these little flanges that come with that water heater to kind of make up the gap. And I'm pretty sure in that video we cover that as well. So that would be on our water heater playlist.
All right, and then she also said she would like to see the carpentry side of it.
That changes. There's some where we've done them and right inside, because a lot of times I'll put a water heater in a spot, so they cut their hole, water heater goes in there, and then we've done a job where the customer wanted to change manufacturers, and we had to cut out the top, but it turns out that was part of a dresser, and it wouldn't work. So he ripped the dresser out because he really wanted this other water heater. But as far as carpentry, yeah, the ones like if you had a rectangular size hole and you wanted to go with a square size water heater, I believe a 2x4 fits in that space. We've done 2x4s in there. And you just got to figure out what to put over it. I don't do, I'm about to give you a name, so get ready to write this name down and go to this guy's website. But I don't do the bodywork side of things, but if it's like a stick and tin RV or if it's fiberglass, I'm going to give you the name Kyle Woodward in Wichita Falls, Texas. His company is RVEMT, and he's got a Facebook page. So if you're in that area and if you're in a Wichita Falls area, he's not coming to, he's a mobile RV service guy, but he's not, wherever you are, he's not driving all over, you got to go to him. But he does fantastic body work on these RVs, and it's something he really enjoys doing. So he would have no problem making a square water heater fit in a rectangular hole or vice versa and make it look factory when it's all done. So you can reach out to him, look at some of his videos on his Facebook. He's got pictures of jobs he's done, things like that. So he's a close friend of mine. We started this. He's been doing this a lot longer than I have. I started my business 10 years ago, and he started his business 9 years ago. But he and I have done jobs together when we started our business down there. So, and then the other one would be Donnie Pullen RV and Trailers. Donnie and Kyle and me, we all kind of started this together all down in Texas. So we're all kind of brothers, what is it? Brother from another mother, kind of thing. So Kyle would be able to maybe give you some tips and tricks on things you could do, or maybe just look at some of his pictures to get some ideas on things you could do. So.
All right, thank you. And so Rick says, first I wanted to say, Sean, we actually started the live stream with your question. So, yay, you got your question answered. Boo, you have to wait till it's all over.
Is that the Wago connectors? There's a 20 amp and a 30 amp.
But I think you can go to our Amazon store and maybe, I don't know, somebody said they saw something on our Amazon store that was out of stock. I'm not sure if that's what it was. So, yeah, we try to keep that updated. Sometimes stuff does go out of stock.
So once this gets published, just go
back and
click at it and watch the first. What, I spent 20 minutes on that question? No, just in the first couple minutes, you'll see the answer.
Okay, so Rick says, what possible reason would a cell switch, motor, and circuit board all go out at once? I have an Atwood 8531.
8531. Okay, so you say the cell switch went out, the circuit board went out. What was the other thing?
Motor.
The motor went out. I can understand how a motor and control board, the DSI board, right?
Circuit board.
A DSI board, direct spark ignition board. Okay, so I can totally get how a motor and a DSI board can fail. I don't know how the cell switch is associated with that failure. That would be a coincidence. But if the motor were to go bad and start to generate more amperage because it's turning really hard, on your DSI board you have that little black relay that's soldered onto the control board. I do see those fail. And you'll know it's failing because you'll hear your board make a click sound, but nothing's coming out of it. So you can take your meter and, you're looking for 12 volts. So you reference ground on your cage, okay? And I like to reference ground on the cage because that's what the furnace thinks ground is. So on my meter, I'm going to reference what the circuit thinks ground is. I'm not going to go to what I know is a good ground. I'm going to go to what the circuit thinks is the ground. And the reason for that, there's been many times I'm troubleshooting something and there's no ground with respect to that circuit. That circuit needs to see its ground path. So the cage of the furnace is fine. Anyway, so you're going to take your, meter in DC 12, you probably already know that. Black lead's grounded to the frame of the cage of the furnace, and then my red lead, I'm going to go to the meter on the DSI board on silk screen in white. It's going to say blower or BLO or something like that. I'm looking for 12 volts at that point. That'll tell me that the control board, given a call for heat, of course, but that's going to tell me that the power is going through that relay to that pin that your motor goes to. So if that failed, then you would hear a click sound. Typically, you might hear a click sound, but no 12 volts. So now you know your DSI board's bad. And for your motor, again, referencing the same ground, but now I don't mean to do a shameless plug, but I do make a test lead set that I've used on pretty much every day I'm in the field. I use this thing. And again, you can get that from our website. Just go to our store, the tools that I make, and it's our test leads. They're the red and black test leads. And I put stacking banana connectors and then an accessory of fitting connector points that I use all the time. And if I use them all the time and you're doing the same kind of work, you'll use them all the time is what I'm thinking. You could buy those big master sets, and there's from Fluke for $300, but it's like, I only need 3 of the things that they're giving me 10 of, you know. Anyway, so by reconfiguring the test lead set, I've got jigs where you can connect it to a 12 volt battery off your drill pack, and then you can feed that motor directly 12 volts. The other thing, earlier we talked about the Wago connectors. You could put Wago connectors on the 12 volts that is feeding the furnace, because you've got a 12 volt power source feeding your furnace. Usually it's the red and yellow, or red and black, or different manufacturers use different colors, but sometimes yellow is ground and they'll use a black for positive, but just figure out your 12 volt plus feeding the furnace. And using Wago connectors, you can kind of connect the motor directly to the 12 volt and just bench test the motor, if you will, right there on the furnace and see if the motor's running. So if your motor has failed, and if motor's pulling more current because it's failed, the bearings are dry and the motor's just really little train that could, really trying to get up to speed, and it's consuming all this current to make it match that speed that it wants. Yeah, I could see how it could burn up that relay on that board. I can totally see that. I don't know that the relay would cause the motor to go bad, but I could see how the motor could cause a relay to go bad. The sail switch, the thing we see happen with those is when the sail switch starts to gets a little dirt on it, it's creating resistance deep inside of that little micro switch, and that resistance that we're seeing, these things are not pulling that much current, not much at all. I mean, think about it. It's going, you're picking up 12 volts from the furnace, well, you get a 12 volt call for heat, depending on if you have a Coleman thermostat, Ericsson thermostat, or Dometic thermostat. They're wired differently in the RV. But anyway, you're going to get one of the blue wires coming back to you. That's the call for heat wire. It's blue. And then that blue wire, different manufacturers wire them in different orders, but one of them is going to go through the high temperature switch, and then it's going to come through the sail switch, and the sail switch is going to make or break, and then it's going to go to your DSI board saying, okay, we got a call for heat. We're not overheated, and we have air blowing through my thing. What we've seen sometimes, yes, the sail switch will obviously fail if there's dirt, dander, cat hair, dog hair up in there, and we've got a video on that. But what we see oftentimes is little dust, especially if there's a smoker in the RV. We've seen this quite often. People smoke, and the furnace is drawing in all that tar and nicotine, everything like that. The sail switch might act perfectly. It might click, 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 click. You could even take your meter on that sail switch, and you can put your meter in continuity mode, and you can actually see the meter continuity, no continuity, continuity, no continuity. So it looks, for all intents and purposes, that sail switch is fine, but it won't allow current to pass through it because the contact points are either fouled out because of and I'll tell you how to know that it's done this, but the contact points might be a little bit faulted a little bit. But when I see that, there's going to be 2 prongs that come out of that micro switch. They're usually like a golden color or whatever. So look at the condition of the prongs that you can actually see with your eye. And if they're a little bit discolored, that's an indication that there's some resistance being built up in that switch. So even though the switch might click, most of the times the cell switches that I replace, there's some discoloration on that pin that you plug your wire into. So why is there discoloration? Well, because there's resistance in that switch. Why is there resistance in the switch? Because dirt or tar or there's little bitty points that actually make contact in that switch. So even though it sounds good and it makes the click and you get your continuity, it may not be enough for the current to pass through it, is what I'm saying. These things will get like it's like a lightning bolt that goes off in these things at a very miniature scale, a little arcing that goes on. And over time, the arcing will soot out the points inside. So that's the sail switch problem. That's the DSI board problem. That's the motor problem. What would cause them all to go bad at the same time? I get the motor causing the board to go bad. Rare, but I can see how a motor consuming too many amps to work if the motor's gone bad could cause the board relay to go bad. Again, it goes back to the contact points. Of course, these are inside the relay on the board, so I can connect those dots, but I don't see how the sail switch has any connection to the motor or the board going bad. So other than coincidence. So anyway, a little bit more detail on how it all works, but hopefully that answers your question on that. But yeah, so sorry that's happening. But anyway, I gave you enough tips and tricks on how to verify and isolate maybe the problem that you might be having.
Yeah, and since we kind of move pretty fast on these, they do post afterwards, and so you can feel free to rewatch it. You can kind of note where we're at in the live stream. I think we're about 30 minutes in. So.
He said an 85-35?
I am pretty sure. Let me just double check.
85-35?
Yep, 85-31.
85-31. Okay. You're going to start to have problems finding parts for those, the older furnaces, the old hydroflames like that. What we're finding is the manufacturer, Atwood, got bought up by Dometic. And so the machines and the presses and all these kinds of things that were used to make that flame spreader, to make those parts, to make that motor, they're destroying those machines to force the issue. Like, okay, we're not going to support this old $30, 30, 40-year-old furnace anymore. And I understand why they do that, because that big heat exchanger that looks like a mitochondria inside the, that's my background in biology, right? Everybody know what a mitochondria is, and the endoplasmic reticulum? Anyway, so you got this mitochondria looking thing inside of your heat exchanger of your furnace. Those develop little micro cracks in them over time. And guess what happens when that happens? Now you get carbon monoxide coming in your RV. So I totally get why it's time just to orphan that whole product. I mean, if it's an 85 series furnace, those came out in 1985 and they just kept going with them. And that's why at the beginning of the series, of the thing we said, we don't need to know that it's in a J-code. That means nothing to us. We need to know, okay, you got an 85-31 furnace, and if you're going to look for parts on that furnace, you really need to know the serial number as well. Because let's say on day one they came out with an 85-31 40 years ago, and well, they sold the 85-31 for about 40 years. The parts that were on the original 85-31 are not the same parts that are on the most recent 85-31, but it's still all called an 85-31. So how do you know how the flame spreader looks? Or they've also changed some of their electrodes. In the older ones, they had 3 prongs, then they went to a 2-prong, the electrode, but it's all an 85-31. But the way we know which one to get is the series of the serial number. So do yourself a favor, if you're going to get a part for anything, whether it's off of Amazon, you do your own shopping, or you're going to go down to your local RV parts store, help those parts guys out. They don't care if it's Jayco or Heartland. None of that matters. What it really matters is the model number and serial number of that appliance. That's what they need to know. That's how they can help you. They might use a program called Magnifinder, and Magnifinder is going to ask, what's the model number and serial number, so we get the right electrode. But anyway, the point I wanted to make on that furnace is it's a much older series furnace. There's a billion of them out there, but they're starting to get harder and harder to find parts for those because they've destroyed the machines that make those parts, to kind of let them get out of the warehouses, and then forcing you, not because they're greedy, because they're trying to keep you safe. These furnaces have been out forever, and they want you to get a newer furnace to keep you going longer. So that's what's going on with having a hard time finding parts.
Yeah, and that's a great topic to address, and maybe we'll just take a couple more minutes to talk about that, because we do get a lot of questions from people who say, the manufacturer is no longer making the parts for my furnace, or what, and they want to know what to do. So you've given kind of some insight into making sure that you have the model number and the serial number, but can you kind of speak to and you've also said there's some safety considerations. And so when we have people that write in and say, they're telling me I need a new such and such.
Sure.
It may be that there's some safety considerations, but what does a person do? What's some best practices
Okay.
or some tips if if say the parts for your particular appliance they're no longer manufacturing? Is it automatically like, do you need to get a new appliance at that point, or do you have some tips for what to do?
I could speak a little bit to that, and I'll give a couple of real world examples. So we were talking about furnaces. We'll just stay with that for a moment. So let's say that I'll just stay with 8531 because that's in my brain because we're talking about it. So let's say you have a furnace. It could be a Suburban, it could be an Atwood, it could be a Dometic. It doesn't matter the furnace, but you need a flame spreader, okay? Which is the part where your gas valve comes through and it makes a right-hand turn, and then it releases a vapor of gas, and then you've got the electrode right over it, and it creates a spark, and now you have this amazing flame inside your furnace. Well, the flame spreaders have changed with that serial number. So you might have an 8531 series furnace, or you might have a furnace that is that same 8531 series furnace. But like I said, just looking at the flame spreader, those have changed over the years. And so you know that based on the serial number. I did a furnace video very recently. And in that furnace video, so it seems like it was just a couple months ago we came out with it. And it was a Suburban. And I think it was a motor. I'm going from memory. And I actually, in that video, I cut into me looking at the part number on the pages. And they will actually say, okay, well, based on these serial numbers, it's going to be this part number, and those serial numbers, it's going to be this part number. And like on a Suburban furnace, that goes from a 2.5-inch motor to a 3-inch motor. So that's a pretty big change. It's still an SF35, but the serial number changes. And on the Suburban serial numbers, the first few digits are the year, and then the month and the day, and then the series. So Suburbans are easy. It's just the first few digits of the year. So anyway, so the reason I'm saying that is because let's say you're going to go find a flame spreader on Amazon. And I can't tell you how many service calls we've been on. It's been dozens of service calls I've gone on because they have a furnace and they go to Amazon, for example. I'm not going to pick on Amazon. It's not Amazon's fault. But they're going to put in flame spreader for an 8531. Oh, here you go. This is the one. Works on all 8500 series furnaces. I'm like, really? Does it really? Really? And at no point in that description of that product on there does it say, they make any reference at all to serial numbers and how they've changed. Well, there's probably 3, I know for sure there's 2, but I'm thinking there are probably 3 different flame spreaders that were used on that 85 series furnace. And the way you know which one to get is based on that series of the serial number. And so if you're going to buy this product, you're going to buy this flame spreader or buy the sales switch or buy the motor on these things, and no one's asking you for the serial number, they're really doing you a disservice because you need to know that. And I did another video, gosh, this one was several years ago. Yeah, this one was several years ago. I think I had back in my day, Pluto was a planet shirt on, so go back and look for that one. And I actually showed the different flame spreaders on a furnace. The holes are different size, the throat inside is different, the angle that they bend is different. Then you have the electrodes that go inside of these furnaces. Some are 2 prongs, some are 3 prongs. But they're all the 8500 or 8900 or the SF35s. How do you know which one? Well, it's all the serial number. So you need to know that serial number. So that's the point there. The other thought I had was, like, some of you have a stove or a range, okay? It's an oven down below, okay? And I don't remember the year. It seems like it was in the last 10 years or so, there were some laws that were changed. So some of the old manifolds in those stoves had some mercury in them that was allowing that you push in to get your pilot light lit and you light it and then you hold it for 30 seconds, you let go. Well, there was a component of mercury in that whole process, okay? And a law was passed, basically, I'm going to paraphrase, I don't know the exact law, but here's the RV technician's version of this law. They passed a law that basically said, unless you have a license, you cannot transport mercury from one state to the other state unless you have all this documentation and paperwork. Well, guess what? So the manufacturers that was making these, which was pretty much all of the oven manufacturers, no longer was that manifold allowed to be manufactured. So they had to, and the reason I know this is because we were working on a Suburban or a Magic Chef. Anyway, it was a stove, and we determined that the manifold, the thing with all the knobs and everything, had failed. Okay, we need a new one. Hey, let's get a normal one. It's part number AB6YZ, no longer available. I'm like, what do you mean? This is a relatively new oven. And so I called the manufacturer. I'm like, how could this part not be available? And then that's basically what I told you is like, yeah, well, they have to buy a whole new oven at that point because there's no parts available for it because of this mercury law. Other instances where laws might change, for example, in '94 on the LP side, if you look at your cylinders, older cylinders, even older regulators, the older cylinders, I'm going off on a rabbit trail, but anyway, there's these laws that changed on the LP, the way that the service valve that goes into the cylinder changed. So the ones we should have today have 3 lobes on them with a tamper-proof screw. The ones from '94 older have like a clover, like a bunch of little ears on it. It reminds me of those little butter cookies that had the little cloves on it. Those are the ones with the put on left, right? POL was the name of a company, but when I say POL with the screws on it. So the service valves have changed. And not only that, the regulators have changed in the LP industry several times. So as people blow up or burn up, I'm making light of that, but as bad things happen, laws gets changed. And so to Trisha's question, like, well, what do you do in that situation? Sometimes your only option is to buy a whole new appliance, especially if like on a furnace that's like maybe 30 or 40 years old. Put it out to pasture, get a new one. You're going to do yourself a favor. You're going to get a much better, more efficient furnace. Might give you better heat, quieter. Who knows? These things are not that quiet. Water heaters, like I said, the Atwood is no longer available. Dometic bought them. The Dometic tank I like. One of the biggest reasons I like the Dometic water heater tank is because the Atwoods had the electric heating element on the back side. And sometimes that is such a pain to get to. We've had to take entire cabinetry on an RV. We had an Airstream one time. We had to take the entire bed, cabinets, everything apart just to get to the heating element on the back of a water heater. You can see it, you just can't get your tools on it. So we had to take an entire Airstream bedroom apart just to get to that. So the new Dometic water heaters, they put the heating element on the front. Thank you very much. So there's all these changes. But sometimes the only option you have is to totally replace that entire appliance. I'll mention air conditioners. Okay, it's not that it's air conditioner season, but back in the early '90s, on back there were pages in the service manual on exactly how to tap and refill the refrigerant inside of an air conditioner. Almost any RV tech that was an RV tech had the tools, knew how to do it, everything. It was so easy to solder on, find the leak, solder on there, tap into it, and fix it. So it's not technically difficult to do that. You can probably get the tools at any auto parts store to do that. But they changed the law all of a sudden. And now, in order for you to do that simple thing that in 1994, it's in the service manual. I've got manuals on our website that it's like an antique document you could read because that's the way they were doing it back then. But today, if you don't have the license from the EPA and all this fancy equipment and all that kind of stuff, by law, you can't do this very simple task and fix the leak and recharge your air conditioner. And if you're doing it and you're caught doing it, you get a fine. So most of your RV technicians, they're just going to replace the air conditioner. Air conditioners, let's just say they're $800. And and that's one of the reasons why on an air conditioner, they don't give you any of the taps. The manufacturer does not give you taps. As far as the manufacturer is concerned, it's a throwaway item. Once it springs a leak, throw it out, pay $800, put a new one on there. Even though you can fix it. And so the strategy there, sometimes we take it off the roof, give it to the customer takes it to an HVAC tech that has all the licenses, they make the repairs, they bring it back to us, we put it back on top. But Darren, my RV Works, I'm not going to jump through all the hoops from the EPA to go get licensed to do this kind of stuff. I'm just going to give you a new air conditioner. So anyway, I could go on with many, many colorful stories. We've done thousands of service calls, but those are just some of my thoughts right off the top of my head.
Okay, that's great.
Sometimes you got to get a new appliance.
Yeah. Okay, so I do want to say that we are done taking questions. So if you have submitted a question, including DNL machine, anybody that has already submitted a question, we will get to it. But at this point, we're not taking any new questions. And let's see. Oh, I just wanted to thank you all for, I mean, first of all, for joining us, but we've just had a lot of people just say some really kind comments, and thank you for letting us know that our videos help, because it's just always encouraging to know that that what you're doing is actually helping somebody.
Yeah. Thank you.
So, okay, so Audio Video Hub said, oh, actually, before I ask your question, David, I'm not exactly sure. I've seen your chats in the stream, but I'm not exactly sure what you're looking for. So if you could just provide a little bit of clarification, if you're wanting like the housing unit for your furnace or something, and you want us to help you locate a part, we're not really able to help with part location, but we can give some tips. But
is it a Suburban by chance?
It's Atwood, 8535.
Okay.
So I'll get to your question in just a little bit, but I'm not exactly sure what you're looking for our help with. I know you mentioned going to our store, but I'm not sure. Okay. So, okay, Audio Video Hub says, looking to replace my 25-year-old duotherm brisk air rooftop air conditioner. What manufacturer and model would you suggest?
Okay, does it have the knobs right on the ceiling plenum, or is it on a thermostat would be my first question. So the reason I'm asking that question is because if you have a thermostat on the wall right here, sometimes go with the same manufacturer, sometimes it works. But if it's that old, that thermostat's going to be old. So if you're going to get the kind that's got the knobs up on the ceiling, you could do whatever you want. Seriously, there's all kinds of air conditioners out there where the knobs are in the front. It's just basically self-contained.
You said thermostat. I don't know if that helps.
A thermostat on the wall?
I assume. I don't know. I wasn't paying close enough attention.
Okay.
Just
if your thermostat's on the wall, that's a love-hate. The gotcha there. Okay, so I'll just go this way, and I know we got a couple other questions. So first of all, you need to determine it's at the 13.5 or 15,000 BTU is the first thing. The next thing you need to ask yourself the question is, do you want it to have a heat pump on it, which basically will heat your RV as long as the ambient outside temperature is above 40 degrees. So you can have a heat pump. Personally, I'm a fan of a heat strip. You don't see those very often, but we've been through some very, 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 very cold winters, way sub-zero temperature, and it was the heat strip that actually kept working and kept us warm. The heat pump would have conked out like days and weeks ago, but when the temperature dropped below. So you have these options, and most of your air conditioners, the heat strip is something you can add on later. Okay, so these are some choices you have, different manufacturers. So then that gets into the question of if you have the thermostat. If you have the thermostat, and let's say it's an Airxcel or it's a Dometic, well, if the thermostat's still fine, great, you could use that exact thermostat on that new air conditioner. But if you go with a Dometic branded air conditioner, Dometic has an SZ1, a single zone thermostat that uses just 3 wires to communicate to it. And I'm a fan of those because on the Suburban, even though the Suburban Airxcel air conditioners, I like those because you could troubleshoot them very, very easily. They're the easiest air conditioners to troubleshoot as a Suburban branded, I'm sorry, Coleman air conditioners are easy, super easy to troubleshoot. The Dometic's not so easy, and what I mean is the Suburban thermostat makes all the decisions with all the wires leaving it, and then so you can actually could put 12 volts on any wire to see what it's doing up top. The Dometic, though, is if you have wires coming down, you just need 3 wires, a plus, a minus, and a communication. It's an RS-232 signal going from the thermostat back up to the air conditioner. And unless you know the handshake and the bits, you can't really tap into that to do it. But the thermostat does have a mode that you can go into to kind of, it's called the manual override mode. And if you need to know the manual override mode on the Dometic SZ1 thermostat, these are the little square ones where they're contact, then sometimes your fingers don't make the buttons work. There's one where the thumbnail of the image is me pointing to one. So it explains how those thermostats work because there's a lot of confusion on them. But anyway, go to the description of that and I give a whole list on how to go into the diagnostics modes on those thermostats and also the error codes on those thermostats. Anyway, so depending on what you have, depending on the thermostat, you could just keep that thermostat and just change the air conditioner that works with your existing thermostat, or change your air conditioner, change your thermostat. The wire's already there. Depending on the wire, like if you have the Dometic that's got the phone cord, You can even use that phone cord to tie into the SZ1 thermostat because you just need 3 wires, and the phone cord's going to have 4. They're little bitty wires, but they'll work. So hope that helps, but you don't have to stay. If you've got an Air Excel up there, you don't have to stay. You can go with a Dometic or whatever. Just it's entirely up to you. That's what's so awesome is you can upgrade. Carrier used to make air conditioners back in the day, and those were like fantastically quiet. And but Carrier got out of the air conditioner business around '08. So I've got an RV that's got 3 Carrier air conditioners up on the roof, and they are fantastic. But you can't get parts for them anymore. But those work. They're still going strong. So too bad Carrier got out of the RV air conditioner business. And Atwood was in the RV air conditioner business for a while. They were coming out of Australia. They had 2 motors on them with variable speed. Those are amazing air conditioners, but yeah, they don't do those anymore either. So anyway, so there's that.
Okay. So Russell asks, how many gallons of propane can you put in a 20-pound tank?
Gallons? You're going to quiz me on that. That's a question I would ask Google. I would. But how many gallons of propane can you put in a 20-pound tank? You can't fill a full, so I'm assuming you're talking cylinder, not tank. Cylinder is the DOT cylinders, your portable. A tank is something that's bolted in, AMSC tanks. So I'm like Mr. LP guy. So anyway, a full 20-pound cylinder is full when it's 80% full. Okay. So how many gallons can you put? Okay, let's get technical. Okay, looking at your collar of your cylinder, you're going to have a tare weight and a water weight stamped on the thing. That is if the cylinder was all the way full, how much water it would consume if it was full. But you have to take multiply that by 0.8, I believe, to get what 80% is. Because if it was full of water, great. But if it's full of propane, you only can fill it 80% because you must allow for expansion contraction. And earlier we talked about propane vaporizing. So a full cylinder of propane needs to be an 80% full tank, so you have room at the top for the vaporization to start happening. So. That is such an easy question to Google. I've got all the formulas, but I don't have them in my head. But anyway, a lot of that information is stamped on the collar of that cylinder. It's going to have the tare weight of the tank itself, and then it's going to have the water volume that it can take. But since we're not filling the cylinders with water, we're filling with propane, you have to deduct that or derate it. So a liquid propane is only 80% full on a full tank. You can overfill those cylinders, but they have this little float thing like you have in your toilet, to keep it to float, and that thing fills up and it's supposed to shut that off. And then when you're filling the tank, there's this little bitty screw on the service valve you let that, it's like a white snowy product, but basically that's propane that's freezing because it's greater than -40. So when that starts to come out, the tank is full. So anyway,
okay.
Good question, but yeah.
All right, TG, I do want to let everybody know, remind you that we aren't taking any more questions, so we've got as many questions as we can answer. So TG says, adding a second AC unit on the front of my 22 Grand Design reflection fifth wheel. Grand Design said it must be Coleman Mach 13.5, but I want a lower profile, not so loud. Your advice?
Sure, yeah.
Yeah, and then he says Truma Aventa or Rec Pro unit. Sure.
Okay, so on that, you've got a couple options. I have put so many air conditioners on RVs. I don't know why they would say it has to be a certain type. The only reason I would think it has to be a certain type is because maybe their thermostat is zone control and it'll work on one air conditioner or one thermostat. I don't know why they would say that. So low profile would work just fine for you. The hole in the RV is 14 by 14 up in the roof. It's a 14 by 14 hole, and I don't think it matters what air conditioner you put on there. If it's pre-wired, then what you should expect to see is a wall plate up in your ceiling that should, it should at least be a 12 gauge Romex wire. I would rather see a 10 gauge Romex wire, but most manufacturers are going to use 12 gauge Romex wire to its own breaker. Now, if it is not pre-wired, you have the exciting opportunity of pulling your own wire, when we've done a lot of this type of install when we were in Texas, and on a 30 amp RV, you can't really put 2 air conditioners on it. Well, you can, but you can't run through that breaker box. And so what we would do then is run its own dedicated power source directly from that air conditioner in the ceiling, and you get the opportunity to fish wires to the walls and get them all down, and then you would come out of the RV. A lot of times we would wire it right next to the shore cord where it connects to the RV, and we would have, here's the 30 amp feeding your RV, and then right next to it we would have like a 20 amp, like a regular receptacle kind, where you could take your own 12 gauge extension cord, plug into that shore cord that we installed, plug it into the pedestal. So that means that that air conditioner is drawing its own power from the pedestal. It's not coming from the RV. And we've even done that on 50 amp RVs, just because they already had 2 air conditioners riding a third. And so the customer just wanted to have that air conditioner totally separate and not involved with the other circuits. But no, you can put whatever air conditioner on there you want. I really don't know why, maybe for cosmetic reasons, but you could put whatever you want to up there. I don't know why they would say that. As far as electrically speaking, I don't think the electron vibrating in the wire feeding power up to it could care less what it's connected to. It's like, no, I'm not going to do this because it's not the right kind of air conditioner. I don't know that that matters. So you got a 14 by 14 hole up there. You got an air conditioner that's going to consume about, I don't know, 10, 12, 13 amps. Yeah, you could go low profile, whatever you want. And we were talking earlier in that topic about if you're going to put an air conditioner on, you have the opportunity to buy one that's got a heat pump on it. You could buy one that's got a heat strip, that kind of stuff. And if you're going to get the kind, if it's like in a bedroom where it's a little bit lower to the ceiling, you could abort having to do the whole thermostat thing and just get the kind with the knobs in the ceiling. It's going to be a lot cheaper for you that way too. So,
all right.
Hope that helps.
And so next is Kyle. Hey, Kyle.
Hey, Kyle.
You know Kyle.
I do.
All right.
Wait, which Kyle? Because I know.
Oh, yeah. No, Kyle over on Patreon.
Okay, yeah, okay. Yeah.
So, yeah. Hi. And hopefully you've made it down to Florida.
Yeah,
and everything's going well there. So he says Norcold fridge doesn't. Oh, I guess you have a customer down in Florida. So that's good.
Awesome,
all right.
Kyle. Good job, man.
Norcold fridge doesn't get cold. LP comes on. Electric comes on. The boiler just doesn't get hot. Laser thermostat says 65 degrees because both heating elements are trying to heat it up. I think the thermistor shows nothing when I test ohms and put cold ice water.
Okay, couple things there. Let's dissect that and just do a talk on diagnosing refrigerator performance issues. Okay, the first, it's when you're going to diagnose a refrigerator, it's highly recommended to diagnose it on AC. It's just less moving parts, okay? So if you're going to do it on gas, you got to make sure you got the right LP pressure, your orifice is clean, burn flame, and all kind of stuff. So diagnosing these things on AC is just give it power and it glows. So the first thing I'm going to want you to do is when your refrigerator is at room temperature and it's not heated up, we need to get an ohms reading on those heating elements, okay? So what kind of refrigerator is it? Is it a Norcold?
Can you let us know, Kyle?
What kind of refrigerator?
I'm not sure that I know.
I don't got a mental block. So look in our book. Again, on our website, we got manuals for refrigerators. And so I do this all the time. And I've come across at a time or two where the wrong heating element was installed in the air conditioner. I did the video. I don't know why. Anyway, so if I say air conditioner, I mean refrigerator. I'm sorry, but it just got some dyslexic thing going on in here. So the first thing I'm going to say is get your service manual where it's going to state the heating element that works with that refrigerator with that serial number. Okay, so we need to know that it's a 325 watt, heating element. Okay, this series. So that's the first thing, because if it's, let's say that somebody's worked on this prior to this and they just put the wrong heating element in it, and this is a symptom that I would see is it just never gets to temperature. Well, because it's got a 125 watt heating element, and it's supposed to have a 225 watt heating element. So that's the first thing we need to eliminate. Now, how do you know what heating element is in it? You could use Ohm's law. There's an app for that. I keep it on my phone. You just enter they have 4 little fields. Just do an Ohm's law app on your phone. And when your heating element is at room temperature, you're going to get your ohms value of that heating element, usually 44, 45, it depends, find out what the spec's supposed to be, plug it into your Ohm's law calculator, and it's going to give you what it's supposed to be. That'll tell you how many watts it is. Check that off the list. Great. So now you know that the heating element is the correct one. You've ohmed it out when it's at room temperature. You know that the ohms are right, therefore your wattage is what it's supposed to be. Plug it in. Make sure that if it's a refrigerator that's got two heating elements, make sure that they both work, okay? I've done jobs where it's a two-element refrigerator and one of them is burned up, and so the other one can't keep up, and therefore you're never going to get that distillation of the ammonia out of the water to get the process going. So we've done all that, and again, because we're trying to troubleshoot this thing, so let's keep it on electric. So now that we've got our refrigerator figured out, we know that our heating element is good. We've done all of our testing to verify 100%, yep, that's the correct heating element and it's good and we're giving it power. You can get your meter to do the clamp on and clamp around a wire to verify, again, like doing, what's that thing called in Excel where you do the checksum, okay? Where I've checked my ohms when it's at room temperature, and that's good. Now I'm going to turn it on, I'm going to clamp around the wire, and I'm going to get my amperage and make sure that the amperage and the ohms kind of match. You're just checking the math value. So great. Our heating element is good. It's getting the exact right amount of current that it needs to consume to generate the heat that it needs. So now the boiler's starting to get hot. After, I don't know, 15, 20 minutes, you should start to feel the boiler getting hot. Depending on your refrigerator, they can go anywhere from 450 to 600 degrees. It varies. But anyway, it should start to get hot. After maybe half hour, 45 minutes to an hour, if you keep your hand on the boiler and you feel the absorber vessels, these round things, looks like a water slide coming down. What's happening is the vapor of ammonia is like a smokestack working its way back up as a vapor, but then the water that we're done with over here that boiled out came back up, and the water is working its way down and the vapor is working its way up, and the ammonia gets absorbed into the water and brought back down into that vessel in the bottom. So it's doing that, but it takes a while. Like a flywheel, it takes a while for all that to start flowing. Okay, that's why I say about 45 minutes or so, something like that. The temperature of the boiler, after the refrigerator's been working for a while, the temperature of the boiler and the temperature of those coils should be pretty close. You could touch them, it's not going to burn you, but technically it's closer to a 10-degree difference, but you're going to keep your hands on those. Now that's a test where you're going to prove if there's any blockages in the cooling unit. It's one big loop that goes all over the place. It involves distilled water, ammonia, hydrogen, and sodium chromate. The business ends are the hydrogen, the water, and the sodium chromate. Sodium chromate is an anti-rusting inhibitor. The water, the ammonia, and the hydrogen are doing all the magic that's making these refrigerators work. The sodium chromate is there just to keep the ammonia in check. Ammonia, these refrigerators are really the story of ammonia. It's all about ammonia changing states from a liquid to a gas, and every time it changes states, it's going to either absorb the heat or shed the heat every time it changes. And ammonia is a phenomenal element to do that, and where we really get the multiplying cooling effect is when we vaporize the ammonia into a hydrogen environment. It's like multiplication of this effect, and that's where the hydrogen comes in, and that's all done up at the top. Anyway. So, we've checked our heating element. We know it's right. We've let the thing run for an interval of time. We've checked our boiler. Our boiler is hot to the touch. We check our absorber vessel. The absorber vessel is hot to the touch. I'm going to say you do not have a blockage right there. Now, let's take the path one of two ways. Your refrigerator's been working for a while. You touch your boiler, and it's so hot you can't even touch it. It's really, really hot. And you touch the absorber vessel, the water slide thing, it's cold. It's not hot at all. In that instance, you have a blockage. Okay, your flow is not going around anywhere, and what's causing that is this sodium chromate we were talking about. Sodium chromate's in there because ammonia is great. It's a story of ammonia, but ammonia is extremely corrosive to steel. It's a very corrosive element, and so the sodium chromate is in that loop just to keep that ammonia in check. Now, if your refrigerator is operated off level, or over time, I've got an RV that I've had since 2000. It's a I've had an RV for 20 years. 24 years. And I've had it, and it's been level the whole time, and guess what? My refrigerator failed. And that refrigerator's been in a couple of my videos. And now I call it my stunt refrigerator, because I've got two RVs with that exact same refrigerator in them. I got one that's working and one that's not. So I'm going to be doing some data logging on, that's another thing. The point I'm trying to make. If there's a blockage, the sodium chromate will start to crystallize, and now you've got like burnt toast floating around inside of these tubes. And if you look at the back of your refrigerator, big tube, little tube, big tube, little tube, and these little flecks of the sodium chromate are floating around, and it'll lodge in from a big tube to little tube, creating a blockage. Now you don't have any more circulation, or very little circulation at all. So that's where the guys say bang on it with a hammer or turn the thing upside down. You're just trying to dislodge this flake of sodium chromate that's floating around in there, okay? But the problem is the sodium chromate has basically come out of solution. It's now crystallized. And so you could break it up into a bunch of little parts, but eventually that sodium chromate's there to keep the ammonia in check. And now that ratio of sodium chromate to ammonia is out of balance, and depending on how much that's happened, the ammonia is going to start to win that battle. Now you're going to have what's called a leaker, and that's where the ammonia starts to eat away at the tubes. And then you have the situation where when you're touching your boiler, and the boiler is kind of warm, but these tubes are very, very hot, that's where you have a leaker. The sodium chromate marker at the bottom, that little yellow powdery stuff that's distilled and that will dissolve in water, the hydrogen has escaped, okay? So now you're boiling your ammonia into a non-hydrogen environment, and you're never going to get cooling effect. So, I threw a lot at you. We need to prove that the cooling unit is good. So, electric, went through all that, touch your boiler, it's either going to be similar in temperature, your boiler's hot, your coils are cold, or your boiler is warm and your coilers are so hot you can't touch them. So it's going to be one of those three scenarios. If they're equal in temperature, good cooling in it, next. If the boiler is hot and the coils are cold, blockage. If the boiler is warm and the coils are so hot, leaker. And you'll also know it's a leaker because you'll see the yellow sodium chromate. Not always. We've done jobs where there's no yellow sodium chromate, there's no yellow anywhere, and it's still a leaker, but we start pulling back the boiler shroud and you see it deep in there. Okay, now, you talked about the thermistor, okay? You talked about the thermistor showing 0. My question then is, what meter are you using, and does the meter go down to that range? We saw that in the video that I did on the tank sensors. Remember, that was a video where I had like 15 of my fluke meters and an oscilloscope and all this kind of stuff, and had this little cheap $30 meter that was actually able to read it. So my fluke meter does not read thermistors. It just doesn't show 0. It's not. So we have it's red. It's on our Amazon affiliate link. It's like a little red meter. It's like $50 or something, but I love that meter. It's just so cute, you know. And so that's the meter that I'm going to want every RVer out there to have, because the problem is your meter is probably doesn't have. And you can look at the spec of your meter, but the meter probably doesn't go down to that ohms value that you need it to. So that's probably what's going on with that. So I know when I'm checking a thermistor, I need to get one of my different meters to read that. We've got a video on checking a thermistor, and I have to, you'll notice in that video that we did, it's not my everyday carry fluke meter. I learned that when I went to a Dometic class, because I'm like, no, my thermistor's bad. And it turns out that we were all talking about it in the class, and a lot of other guys were having the same problem. Well, then this guy over here had this cheap little Harbor Freight meter, and it was working. And so like, oh, wow. So the reason you're getting a thermistor open value is because your meter probably, I'm saying, doesn't go down to that range that we're looking for. A healthy value you're looking for, like 8,000 ohms, is typically what we're looking for, around 8,000 ohms of resistance. So make sure your meter can go down to that range. So a lot of information there. Hopefully I've given you enough information to either diagnose the heating element, diagnose a cooling unit, and diagnose your thermistor. And so let me just pause with that, do that homework, and then if we'll be on the Patreon side here, and then we can go deeper into it, and then on the Patreon side I can go into the whole gas side. The gas side's got a lot more moving parts to it, but all things that you can diagnose and fix. The biggest offender I've seen on the gas side is that little orifice right where it comes out of the gas valve. Those orifices are famous for being clogged, and people can clean their burner, but they forget that orifice. And so you got to clean that orifice. And when you clean that, only distilled isopropyl alcohol. You're not going to take your what's that welder? Not the stick welder, but the TIG MIG. You're not going to take your MIG welder. Those little files that you use to clean your nozzles out. You're not going to take that and clean that. That's wrong. Sometimes those are found out. So anyway, I'm going to pause on that and jump into some other questions, but hopefully that benefited a lot of people on how to diagnose these refrigerators. It's all about the field. Make sure your heating element is correct, and then do the field test, FEEL test, and make sure that it's got good circulation. And then that's the first thing you do, and then there's other things that you do beyond that, but that'll catch a lot of it right there. So
okay.
Let me jump into more questions.
That's great. And I'll just go ahead and tell you what his comments are,
Okay.
just in case
Okay.
there's any additional information there. So it's a Norcold N8X.
Okay.
He has a
Yep.
Klein's
Single
meter.
element. Klein, okay. See if the Klein goes down to 8,000 ohms.
He checked the heating element. The numbers were all right.
Okay,
He
good.
talked about that. He got the service manuals from our site.
Excellent, good.
It's acting like it's getting a signal that it's hot enough. Boiler is cold, coil's cold.
So it's getting the heat, but the boiler is never getting hot. I'm gonna. Okay, so if I know if you've proven that heating element, I'm sorry, if you've proven if you have proven that the heating element is the correct spec, and you've proven that it's consuming the amount of current, and that boiler just cannot get to temperature, I'm starting to suspect the cooling unit itself. I'm starting to suspect that. The cooling unit itself is a sealed unit. It's under pressure. I'm wondering if it's lost pressure and it's not able to generate the heat. So in that instance, if we know that we're generating the right amount of heat, and we know that because we can take our clamp meter and clamp around the wire feeding that heating element, and it's right where we expect it to be, and the cooling unit is not able to perform at the boiler, and the boiler is not getting hot, now I'm starting to highly suspect that there's an issue with the cooling unit itself. And if you need to replace a cooling unit, we've got a couple videos on that. We get all of our cooling units from Cool Fun RV out of California. We've been through a couple other manufacturers, but we've been with Chris with Cool Fun for a couple of years now, have never ever had a problem at all. Fantastic workmanship. So if it is a cooling unit, I've got a couple videos on how to replace those. On the N8, I think I've got a video of me swapping a cooling unit out on that size refrigerator. I think we do it standing up instead of laying down. We couldn't get it done. So I love doing cooling unit jobs. It's a 4 to 6 hour job, but I enjoy it because it's something you really sink your teeth into. The flat rate for those pays really well, and I just feel really good when I'm done because I know it was a big job, and you just know when it's done right. And so I enjoy doing cooling unit jobs. So I hope you do too. But yeah, book out some time to get it done. But yeah, watch our videos. We've got a couple of videos on cooling unit jobs. So watch a couple of them. Every video I'm offering different tips and tricks on it. But if you're getting the heat feeding that boiler, and that boiler is not getting hot, then you don't have any circulation. I'm really suspicious on that. And honestly, Norcold, I love you, Norcold, but they have had, I've done more Norcold cooling unit R&Rs than I have done Dometic. They've got a real issue with some of their cooling units. Don't know why, but they do, especially the 1200s. Of all the cooling units I've done, and I've done hundreds and hundreds of cooling unit jobs, I've done more Norcold 1200 series cooling units than any other cooling unit out there. And then the N8s, we've done quite a few, and then we've done quite a few Dometics, but Norcold by far we've done more cooling units from the Norcold refrigerators. So.
Okay, and DNL Machine says trailer water heater, no anode style, gas heat works, shore power electric works, but only makes about half the heat. Any suggestions? Okay.
So if it doesn't have an anode rod, then I'm going to assume it's an old Atwood. It's got a plastic plug on the drain. So water heater makes, okay, so I got a couple questions there. Okay, so you need to back flush that water heater. And that is not the same thing as draining the water heater. Back flushing, I keep saying we got this. We got videos on back flushing the water heater. That is an active process where you're blasting out all the crap that's in the bottom of that tank that you cannot get to by just letting it drain. So that is to say, if your heating element is embedded in a lot of this calcium buildup, it's never going to really work because you're having to heat up all this calcium, and then maybe you can heat up the water. So let's start with a nice blow out a water heater. In fact, I don't have my phone with me. I'm going to show you guys something. I got a video. Give me a minute. This is worth the pause. My phone's over here. Let me reach for that. Hold on for a second. Okay. So let me pull up a video. I'm going to show you. I took a borescope and I stuck it inside of a water heater recently. And I'm going to show you what's inside of your water heater. So it's right here. It's coming up. It's coming up. Ooh. Oh, we're so close. Right here. Okay. So here, I'm just going to hold this. Tell me when it's in focus. Tell me if that works. Is that working?
Pretty well. It's a little flashy, but I think they get the point. Yeah. Oh, no, that's just because it's your video you're playing.
Yeah.
Yeah, yeah. No, it's coming through.
Okay. So that, and then I've got, here, I've got, so there's that one too. Is that good?
Pretty good.
Okay. So I took a whole bunch of pictures inside of the water heater with my borescope. It was very exciting. And the other thing is that water heater has ruptured. And so we're going to get our hands on that water heater, and I'm going to keep that water heater and very carefully slice the top off and very carefully to see that, and I'll be making a video of that. So if all that is in your water heater and you're trying to heat it, get that out of your water heater. So the way you do that, you get the little wand, you screw your garden hose to it and blast it out. Okay, so there's the first thing. Now you're going to start with a nice clean water heater. The next thing I'm going to want you to do is you can check your heating element. We just talked about the refrigerator heating element, doing ohms and all this kind of stuff. So what you're going to do with your heating element on your water heater is you're looking for 10 ohms on your water heater heating element. So take the cover, turn off the power, okay, take the cover off. Was it a Suburban or an Atwood?
GC6A.
It's an Atwood.
Okay.
It's going to be on the back. Okay, so you can do this from the actual, that's a little tougher. You could do it from the breaker panel. It's a little bit tougher. I'm not going to go into how to do that. So that's heating element's probably going to be on the back. But anyway, try to gain access to your heating element. Take off a little, on the Atwoods, you got this little black box with little funky screws you got to take off, and they don't give you a lot of room to take off these really long screws. Why the screws are so long, I have no idea. But anyway, you're going to get to the back of the heating element right there. You're going to take off one of the wires. Does not matter if it's neutral or the hot, doesn't matter. But then you're going to take your meter and you're going to put your meter into ohms, and you're going to touch, with one of the wires off, you're going to touch that heating element, and what you're expecting is 10 ohms of resistance. Looking for 10, okay? If it's not 10, then your heating element is probably compromised. And I've saved some of these heating elements, and my show and tell collection in my shop is building, and I'm doing some construction projects back there, so I don't have a studio like I used to. If you look at my old video, I'm sitting on my bench, and the whole back field has changed now. So I'm just doing some construction, but I'm keeping all my things. But anyway, the heating element, sometimes they burn holes in them, and or it just looks like this tertiary structure all mangled, like a protein all twisted around on itself. But on yours, it might still be okay, but let's just verify that the heating element is 10 ohms of resistance. And then when you put your wire back on and you get your clamp meter and your water heater is on electricity, on AC, and you clamp around a wire, what you're looking for there is about 11 amps, okay? 11 amps of power, 10 or 11 amps. So it's 10 ohms and 10 amps, or 10 ohms and 11 amps. What that's going to indicate to you is that the water heater heating element is consuming what we expect it to consume to generate the amount of wattage that it's generating to heat the water. So we've started with cleaning out our water heater. We've verified our heating element is good. So if I was on a service call and somebody had this issue, this is what I would do. I would back flush your water heater. I would check your heating element, make sure your heating element was within spec. Now on the gas side, you said it's an Atwood or a GC, so that's the one that's got, that's the one that's got the little slidey thing that you human need to change on your altitude. There's an orifice on those. You got to make sure that you might check your LP pressure. You need a manometer to do that. It's like checking air on your tires. So you're going to need a manometer, but you're going to want to make sure that the little brass orifice that is screwed onto the end of that, so you're going to take your burner out, that little J-tube burner thing out, and then that little screeny thing that you could slide, you're going to move that out of the way, and that's going to leave you with this little, I want to say it's a 10 millimeter, but I just don't remember. You're going to take this little brass thing off, you're going to make sure that's not fouled out. I have seen where insects get inside of there and they make a little house inside there, and that's restricting your gas flow going through the J-tube, the J-tube part. And we've also seen, look inside that J-tube, I get a can of that little office air or whatever, pipe cleaners, and clean that out. Spiders like to make a nest in there. So these are all the things that can restrict the proper amount of gas, vapor, to make it through that little orifice, through the J-tube, right into that little deflector thing that it hits, and make sure your little anode or your little electrode right over it to create this nice flame. Okay, so gas you might have a bad heating element. Now, having said that, I've gone through all that, but I want you to check something first. It's the low-hanging fruit. I want you to make sure that the water heater is not in bypass mode, okay? Low-hanging fruit, it's a simple thing, and I can't tell you how many jobs I've got on. I try to talk them through it before I get out there to save them some money. But on the back of your water heater, you're gonna have where the hot comes out on the top and the cold goes in on the bottom. Different manufacturers do it different ways, but sometimes there's a pipe that connects the two, okay? So you're gonna have a shut-off valve here, and yeah, here we go. So here is the back of your water heater, and here's water going in, and so here is hot coming out, and here is cold going in, okay? And then a lot of times they'll have a valve right there, and then they will have another pipe, something like that, okay? So if this one is turned off, okay, so you close this valve, and you close this valve, and you open this valve, and so cold water is bypassing your water heater, so cold goes like that, okay? But if you were to close this valve, close that valve, open that valve, I'm using X and O, open that valve, then it's not gonna do this. The water's gonna go in and come out. So what we have found many times is that this valve is also open, okay? So now you have a blender. So cold water's coming in, hot water's coming out, but cold water's also going this way as well. So very simple thing to do. I want you to do this first before you do all the other complicated stuff I said. Make sure that valve is closed, okay? It may not be on the back of your water heater. Sometimes the manufacturers will have a bypass, but it's somewhere else in some wet bay or depending on your manufacturer. If I need to draw again, I'm gonna need to get my pen. So make sure your bypass valve is, this is called the bypass valve. Make sure that's closed, and then cold can only go in, hot can only come out. Sometimes, let me grab my pen, manufacturers, oh man, it's reaching, okay. Sometimes manufacturers will put a check valve right here coming out of the water heater where water can only go in one direction. I like that, even if the manufacturer didn't do it. I like that because you're taking a shower, maybe it's a military shower, and you've got hot water that you're flowing on, or all this kind of stuff. You need to turn that water off. If you don't have a check valve, then all that hot water is gonna go back into the tank, okay? But if you put a check valve in, even you yourself, then it can only go that far. It doesn't go in the tank. So you know that this line here has always got hot water in it, right? As long as it's flowing. They do have the kind that C-Tech makes them. I'm pretty sure I've got some on our Amazon store. I've got a picture of it. Anyway, you could just cut your PEX line and put your check valve here. I took a picture of one for a buddy just recently. Chris, if you're online, this is you I'm talking about. Another RV tech guy. So I'm going to show you a picture of the check valve I'm thinking about. And then we'll go to the next question. Right here, okay. How about, can y'all see that picture right there? Yep. Okay, so that is a C-Tech fitting. Get them on Amazon, I believe. You'll see a little arrow that says flow. So that is not a union, that is a check valve. It's got a little valve inside that allows it to only go in one direction. But that's a C-Tech, that says patent. So this is an upgrade you could do to your RV. Anybody could do this. So get yourself one of those. It could even be a shark bite that you get at Home Depot or Lowe's. But it's a check valve that you cut your PEX line and you slide that thing in, and that's going to keep your hot water from flowing back into your tank. And that way, when you go to do your shower again, you're not having to run more water because you know that this is charged full of hot water. So anyway, so make sure that's turned off. And then make sure your heating element's a spec, and then make sure your gas line has got good gas pressure and that your little brass orifice is clean.
All right.
I'm done. Okay.
Thank you. Okay, so our final question will just be you trying to, do you want to try to settle an argument?
Oh boy, I love that. Yeah, I'll be a mediator.
Okay, so Elrad says, do you need 2 regulators to run a generator setup, 90,000 BTUs, or can a high flow regulator work? All appliances and generator running at the same time, 18,000 BTU max. And you have 60 seconds to respond because we need to finish up.
Okay. The answer to your question would be, to do this correctly, you need to go to every single gas appliance in your... So the answer is one regulator, okay? How's that? So the way you determine these things is you go to every single gas-consuming appliance and you write down the BTU rating at the input. They're all going to have it listed there. And then you're going to get a number, okay? And then I like to go to Marshall Excelsior website, and you're going to download their little brochure with all their stuff. The first 3, 4, 5 pages are all about regulators. Okay, so read that. There's a couple typos in it, and I wanted to write them and say, hey man, you didn't spell this word right, or you need a comma here. So just look through the typos. They even have some incorrect math on one of their charts that I found. So ergo, you got to read the manuals. Anyway, though that is phenomenal information on regulators, the standard flow, the low flow, and the high flow. So now that you have written down all of your appliance consuming LP appliances, you have a number, okay? The regulator you choose needs to be able to satisfy that. The 50% load test is you take this number and you divide it in half. That's your 50% load, but you're not asking that question, you're asking about the thing. So one regulator, if you really have a problem, then you can go directly to your generator with its own system that's not part of your RV system. It's its own separate system. Some generators consume LP as a liquid, okay, but most of them consume LP as a vapor. But if you really are concerned, then you can do the generator as its very own LP source, its own cylinder, its own everything. It has nothing to do with the RV, and you could do it that way too.
All right.
Is that 30 seconds?
Fantastic.
Okay.
Yeah. Okay. So thank you for joining us.
Thank you.
That wraps up our monthly live stream over here on YouTube. We do go live every month, the first Friday of the month at 4:30 p.m. Pacific time. So we will be going live next month will be Friday, March 1st at 4:30 p.m. Pacific time. Right now, what we're going to do is we're going to jump over to Patreon. And so our patrons get access to about an hour more bonus live stream. And they get that every month as well. So I do want to encourage you, if you want to be the first to know when we have something coming out, you can join over on Patreon. You can join there for free. And as a member over on Patreon, you'll get to know what we're doing first. If you are interested in joining our exclusive monthly live stream over there or any of the other benefits, you can join for as little as $5 a month. So go ahead and check us out. I think it's patreon.com/myrvworks. And it's in just about every one of our videos. You can find the link. So hopefully you'll join us over there, and we'll look forward to seeing you either in a little bit or in a month.
Okay. All right, guys. Thanks.
See ya.
All right. Bye.
Bye.